This week we will be finishing off chapter 4 in our logic course, and section 4.4 is where we're going to start, and that talks about conversion, obversion, and contraposition. All right, so conversion is where the subject and the predicate in your statement switch places. So here's the given form, and here's the converse for each. So you might want to press pause and write these in your notes, but here are the event diagrams for both the original form and the converse of each form. All right, so that's all. Conversion just switches your subject and your predicate. So they're just going to change places. That's all that happens. So notice that E and I statements have identical Venn diagrams as their converses. Therefore, E and I and their converses are said to be what's called logically equivalent statements. All right, and again, for E and I, you can start building inferences from these specifics. So no A are B, therefore no B are A. Some A are B, therefore some B are A. And since the premise is true, the conclusion must be true. However, that only works for E and I, so be very careful. It does not work for A and O. For those forms, when you do this, you end up getting a fallacy of illicit conversion that we talked about back in chapter 3. All right, obversion, okay, is where you change the quality, not the quantity. So you replace the predicate with its complement, with its term complement. So if you say all horses are animals, the obversion would be no horses are non-animals. And again, here's your four statement forms and their obverses. So you might want to press pause and take some notes about that. Okay, so again, when you do the obversion, okay, the second step requires the understanding of what the complement is. So remember that the complement just means the opposite, right? So if it's animals, the opposite is non-animal, right? So you just got to make sure you know the opposites. Notice that the Venn diagrams for the statement forms and their obverses would be identical. So very important. Couple of notes about obversion. For all the inference forms are valid in this case, since that if the premise is true, it follows necessarily that the conclusion will be true. So if all A are B, then no A are non-B. Okay, so it follows true for all the forms, so you don't have to worry about A and E and I and O, A and O. So the last one we're going to talk about is contraposition in this section, and that's where the subject and the predicate switch places, and you replace each with its term complement. So if you start with all horses are animals, the contraposition would be all non-animals are non-horses. So notice the animals and horses switched, and you put a non on each of them. And then there's the given form and the contrapositive Venn diagrams for all. Okay, so from those Venn diagrams, you can see that A and O have the same diagram as their contrapositive. So A and O and their corresponding contrapositives are all logically equivalent, but E and I, they're logically undetermined. We don't know we don't really have one way. It could be, it might not be. So A and O, contrapositives are always logically equivalent. For A and O, you can start building inferences for these types. Since the premises are true, the conclusions. However, E and I, those have illicit fallacies, illicit contrapositions when that happens. So again, it's a lot. I know it's a lot to keep track of. So this is where you're taking notes and you're writing it down in a way that you can remember or you can quickly reference it, is going to be really important. All right, so summing up, I know some of you like little things that you can look at. When it comes to conversion and contraposition, conversion works for E and I, and contraposition works for A and O. So if you line them up, E and I go together and A and O go together. So you're just going to have to find a way that helps you remember. I'm a big fan of writing down little, anagrams or mnemonic devices or that kind of thing. So anything that works for you. In your book, they actually have these three little charts that I like, one for each. So if there's any way that you could, memorize this, or put it in your notes, whatever you want to do, that will help you remember. In section 4.5, we talk about the traditional square of opposition. And this looks at Aristotle's standpoint that universal positions, propositions about existing things have existential import. So if it's contradictory, A and O and E and I are kind of the same. They're the ones that are across from each other on that modern square, because we talked about the modern square before. And contrary just means that at least one is false. So your contraries are A and E. Contradictories are A and O and E and I. Contraries are A and E. Your subcontraries are going to be I and O, where at least one is going to be true. And then there's something called subalternation. And this is where truth flows down from A to I and from E to O. So you'll notice here, subalternation right here, here to here. And falsity flows up. So falsity goes from O to E and I to A. And again, all these, explain, if you really truly understand this square, it'll make your life so much easier. So, and I've seen a million different, I had a student send me this next one. This is one that another student said they found online and it helped them remember. I don't know. I just look at that and I go, wow, that's a lot of arrows going everywhere. But it's about, if it's true, then this is false. If this is false, then this is true. If you're talking about contradiction, and this is your subcontrarity, and this is your subalternation. Again, you use whatever maybe you'll go do some research and you'll find something online that you like, whatever helps you. I'm a big fan of anything that'll help anybody. So when you're testing your intermediate inferences, a couple things we need to look at. So let's just do an example because it's a little bit easier. All Swiss watches are true works of art. Therefore, it is false that no Swiss watches are works of art. Okay, so from Aristotle's standpoint, this existential fallacy is committed only when the contrary and the subcontrary and the subaltern are correctly used to draw inferences about things that do not exist. Swiss watches exist, so you don't really have to worry about that. Why did I have that example there? I don't know. Sometimes I go back and wonder why I had these examples on here. You know how that is? You put it in at the time, you're like, this is a great idea. And then you're like, wait a minute, why did I have that there? So the premise and the conclusion are linked by the subcontrary relation. According to that relation, if the premise is true, then the conclusion has an undetermined truth value. So the inference is invalid. So this is what we call a form of fallacy that we talked about back in chapter 3 of the illicit subcontrary. Inferences that depend on incorrect application of that contrary relation commit what's called a formal fallacy of illicit contrary. And inferences that depend on it, on those illicit applications of subalternation, commit a formal fallacy. So the fallacies are just named after the thing that they're not following. So again, if you know the square, you'll know what fallacy they are committing. So I had some examples here, so I'm not going to read them to you. You can press pause and read. Conditionally valid. This applies to an argument, again, from just Aristotle's standpoint, when we are not certain whether the subject term of the premise actually denotes an existing thing. So like all cats are animals, therefore some cats are animals. Now, for the Boolean, it would be invalid because it's committing an existential fallacy. But Aristotle would say it's valid because we know cats exist, right? All unicorns are animals, some unicorns are animals. Boolean, again, it's still invalid because of the existential fallacy. Aristotle, it would automatically say it's invalid because we know unicorns don't exist. So these are things that, you have to keep in mind, depending on which standpoint you're looking at it from. So when you're testing for validity, I'm just going to go right to the example that I have because I think that kind of sums it up. All cats are dogs. Therefore, some cats are dogs. Okay, the premise is obviously false here, right? All cats are not dogs. We know this. But if you assume it's true, if you assume that all cats are dogs, then it follows by subalternation that the conclusion must be true. Because if all cats are dogs, then some cats would have to be dogs. Thus, the inference is valid. However, because the premise is false, the inference is unsound. Again, remember, valid and sound don't mean the same thing. So we have a valid argument that is unsound and commits, no fallacy, because depending on what viewpoint you look at from. All right, so let's try some examples. All right, and again, you're going to get them wrong. You're going to have to practice. Don't feel bad. Everybody messes these up, so it's just one of those things that you have to practice. Some unicorns are not gazelles. Therefore, it is false that all unicorns are gazelles. Now, we can talk about this from a couple different standpoints. So the premise asserts that unicorns exist. Okay? The premise seems self-contradictory. So if the premise is assumed true, then the conclusion must be true by the contradictory relation. Thus, the inference is valid. However, the inference is unsound because it is a false premise, right? Some unicorns are not gazelles. Gazelles are gazelles. Unicorns are unicorns. Okay, so these are the things you really have to think about in logic, right? You really have to tear them down. And that's why going back to, symbols is going to be really important rather than worrying about the words. In section 4.6, we're going to go back to those Venn diagrams and kind of do the Venn diagrams along with the traditional standpoint. So again, Aristotle, very important. We're going to start putting some circles around those X's. And that's going to help us remember, existential import. So all S are P, no S are P. So again, finding a way to remember these Venn diagrams is going to be helpful because if anytime you see this setup, this is what it's going to look like, regardless of what the words are. The only difference between Boolean and Aristotle's standpoint concerns, again, remember, only A and E. Those are the only two you have to worry about. I and O, doesn't matter. In the Boolean, universal propositions have no existential import, but Aristotle, universal propositions do have existential import when, again, this is subjective, when their subject terms refer to actually existing things. So the Venn diagram uses the X circle to signify that something exists in that area in which it is placed. So again, that little circle around the X is going to help you. Here is those four Venn diagrams with the traditional square of opposition. So notice how so you can look and see how everything flows. You can see how we go from here to here and from here to here. And then you can see when we go across with our contradictions as well. So it's kind of nice to visually see it along with the arrows so that you can kind of get a feel for how everything flows. All right, so the four relations in the traditional square of opposition are contradictory. That means they have opposite truth values. Contrary, which means at least one is false, so they can't both be true. Subcontrary means at least one is true, which means they both can't be false. And then you have subalternation, which means the truth flows downward, falsity flows upward. All right, so if your inferences are valid, they have to be valid from both Aristotle and Boolean standpoints. Invalid Boolean references may be valid from Aristotle's standpoint, so you have to kind of be careful of these things. So you can test an inference form for validity from the Boolean standpoint and then test it from Aristotle's. So Boolean is the one on the left. Aristotle's the one on the right. So test them both. Sometimes I think your book is very straightforward. Usually it tells you exactly which one to do. Like it's going to say from a Boolean standpoint, blah, from an Aristotle. So it'll tell you which one. So when you test a complete inference form for validity from the Boolean standpoint, here's an example. And then, since it is invalid, you're going to have to adopt your Aristotle standpoint, and this would be then your Venn diagrams. Notice the difference, right? They're the same, except this one, there are some P that exist. All right, so here's an example that we can walk through together to kind of help you out. So all sugar plum fairies are delicate creatures. Therefore, some sugar plum fairies are delicate creatures. Again, all S are D. therefore some S are D. So get rid of the words, put in those symbols, draw your Venn diagrams right away. Okay, so the inference, immediate inference has the same form as the first one we tested. The form is not valid from Boolean, but it is conditionally valid from Aristotle. And notice, I put a little note over here. See, so notice that the final step is that you see that circled X. So that means at least one thing exists there because, and notice it says the circled X is in the S circle and S stands for sugar plum fairies, which do not exist. Thus, the requisite condition is not fulfilled and the inference is not valid. The inference commits that existential fallacy. We know sugar plum fairies do not exist, except in ballet. And again, so here are the steps. Please feel free to press pause. I don't want to read this to you because I know you can all read. So press pause, read it, take some notes. And the last section is section 4.7, which talks about how do we take ordinary language and change it into categorical form. So if a term consists of only an adjective, a plural noun or pronoun should be introduced to make the term genuinely denotative. So some roses are red. Well, rather than just saying red, why don't we say red flowers? Because we know roses are flowers, and there are flowers that happen to be red. Some of the roses anyway, not all of them. My favorite ones are the yellow ones. You could have non-standard verbs. So like some college students will be educated, they'll become educated. So you might need to rewrite that as some college students are people who will become educated. Slightly different, but it makes it flow a little bit better with our different forms. So you might need to change the verbiage just a little bit to make it work. Okay, so if you have a single proposition and then use of parameters. So this proposition makes an assertion about a specific noun. Okay, so like George went home. Okay. All people identical to George are people who went home. So notice we had to embellish it just a little bit because we can't just talk about George himself. We got to talk about people who are just like George and people who went home because some people stayed home and didn't go home and they stayed wherever they were. Adverbs and pronouns. He is always clean shaven. Okay, you may have to clean that up a little bit. All times are times when he is clean shaven. Okay, always means at all times. So that's why they changed it to all times are times he is clean shaven. So again, you might have to embellish the language just a little bit to get it to fit what we need for our forms. You could have unexpressed quantifiers like all emeralds are green gems. Oh, no, emeralds are green gems. Well, by emeralds, we're implying every emerald. So all emeralds are green gems. You could say there are lions in the zoo. Okay, well, yes, there are. But to fit our forms, some lions are animals in the zoo. Right? Not all the lions are in the zoo, just some of them. You might have non-standard quantifiers. So like a standard quantifier would be some soldiers are heroic. Well, they might say something like a few. Well, a few is just another way of saying some. So you might need to change the words just a little bit to get them to fit the quantifiers that we use. Conditional statements. If it is a mouse, then it is a mammal. All mice are mammals. Okay, if it is a turkey, then it is not a mammal. No turkeys are mammals. So again, if-then statements, right? Your conditionals. You may have to tweak those a little bit. You may have exclusive propositions like only, none but, none except. So none, that'd be no, right? None would be, okay, so none but the brave deserve the fair. That's the original. Now we could rewrite it as all people who deserve the fair are brave people. So if it's a none, you may have to change it to an all to get it to work. Or maybe you can just keep the none and change it to a no. So again, it just depends on the language. The English language is a very difficult language when it comes to this kind of thing. Only statements. The only animals that live in this canyon are skunks. Okay. All animals that live in the canyon are skunks. That fits what we need. So if you start with the only, it's translated a little bit differently than if it starts with only. And then the last one, acceptive propositions, take the form of all SRP and all but SRP. So I'll accept SRP, all but. So those you might have to tweak a little bit as well. So here are some keywords and some hints. And again, I just took these right out of your book. It's very nice. I just snipped them. So practice. It's going to take time. You're going to have to find ways to help you remember. There's no one size fits all. Like I said, I'm a big fan of, like, I print out the formula sheet that I have posted, and then I just make little notes on the side and put stuff. So have like a nice study sheet that you use when you're going through from chapter to chapter. I think that will really help. So go practice, and we'll see you next week.